Hello students, welcome to the third lecture on the lecture series on permutation and combination. Okay, so in the first lecture on the lecture series on permutation and combination, we discussed all the type of basic concepts and what is permutation and all the kind of questions that are usually being asked on the topic permutation on various competitive exams. Okay, and in the next lecture, we discussed what combination was and how it was actually different from combination. Okay, because permutation means what? Order matters, right? But combination means order is not considered or does not matter, right? That is what combination was in terms of what, how it is characteristically different from permutation. Okay, so we also discussed in the second lecture that what combination was, and then we discussed the kind of questions that are usually being asked on combination on various competitive exams. Okay, so in this lecture what we will do is we will do some exercise problems. Okay, so that all the kind of concept that you learned in permutation and its combination, you can actually apply all those concepts to this exercise, so that you could actually remember all those things without actually what, writing those things out. Okay, so let's go forward and do some exercise problems so that we could actually get a better grip about these topics permutation and combination. Okay, so this will be the part 3 and let's do the exercise. Okay, so problem number 1. So how many different 3-letter words can be formed using the letters A, B and C if repetition is allowed? Okay, so how many different 3-letter words? Okay, so the only options that we have is 3 options. Okay, so the pool have A, B and C, where we can actually choose the letters. Okay, and we want to make a letter of what, 3 word. Okay, letter consisting of 3 words. So in the word first letter there must be some positions that are assigned, right? So 1, 2 and 3 positions are there. Okay, so we want to choose what, 3, actually we want to what, place. Okay, repetition is actually allowed here. So for the first option what we have is we have 3 options, right? So A can be here, B can be here and C can be here. So 3 options. Then we multiply with what second position have. Okay, what it can actually have, it can have A, B and C. So 3 options are there. Okay, then we multiply with, since third position also have the same options A, B, C, so we can multiply with, so it will be 3 power 3, it is equal to 20. 7 choices are there to make a letter out of it. Okay, so for each of the 3 positions, okay, the first position, the second position and the third position, you have 3 choices ABC. Here you can place ABC, here you can place ABC, here you can place ABC. So 3 choices for this, 3 choices for this, 3 choices for this. Since repetition is allowed, the number of different 3-letter words will be 3 power 3, that is equal to 27. Okay, so let's actually go forward to the second question. Okay, so in how many ways can 5 different books be arranged on a shelf if 2 of them must always be next to each other? Okay, so what it tells us is what we have is 5 different books. Okay, they are clearly distinctive different. Okay, so 5 different books are there. Okay, so let them say B1, B2, B3, B4, B5. Okay, there are 5 books, this one, this one, this one, this one and this one. Okay, so there are basically 5 books. Okay, so we want to arrange them on a shelf if 2 of them must always be next to each other. So let's assume that those two be B3 and B4. Okay, so actually no, what we have to do is on a shelf if 2 of them must always be next to each other, so what we have to do, so how can we choose out of 2 out of this 5? So it will be what, 5C2. Okay, because we want to only choose. Okay, while choosing the order doesn't matter, only those 2 matter. Okay, choosing those 2. Okay, so it will be 5C2 ways are there. Okay, that will be equal to what, 5 factorial by 3 factorial into 2 factorial, that will be equal to 5 into 4 by 2 is equal to 5 into 2 is equal to 10 ways. Okay, so then how can, so let's assume that B3 and B4 are always together. Okay, so let's consider them the B dash. Okay, so B1, B dash, B1, B dash, B4 and B, sorry, B2, and B5. These are there. Okay. So in how many ways we can actually order these 4? Okay. So it will be what? 4C. How many way? So it will be in 4C, 4P, 4 ways, right? Because there are 4 books and we want to order them. Okay. So it will be 4 by 0 factorial is equal to 4 factorial ways are there. Okay. So while choosing what? B3 and B4, how these two can be arranged? Okay. In how many order? How many ways? So it will be what? 2 factorial ways, that is equal to 2 ways. So basically the answer is, in how many ways can 5 different books be arranged on a shelf if 2 of them must always be next to each other? Okay. So it will be always what? It will be what? 4 factorial into 2 into 10 ways. Okay. This amount number of ways. Okay. So let's go forward to the next question, that is problem number 3. So in a class there are actually 27 boys and 14 girls. Okay. So number of boys is equal to what? So number of boys is equal to 27. Okay. So and number of girls is equal to 14. Number of girls is equal to 14. Okay. So the teacher wants to select one boy and one girl to represent the class of for a function. Okay. So in how many ways can the teacher make this selection? Okay. So in a class there are 27 boys, 14 girls, right? So the teacher wants to select one boy and one girl to represent the class for a function. So in how many ways can the teacher make this selection? Okay. So how I can actually choose one boy from 27 boys? Okay. Here only one boy is there, so choosing or permuting doesn't really matter. Okay. Because we are actually selecting one, so there is no different order than what the already established order. Okay. So it will be 27C one way. Okay. And choosing what? 14, one girl out of the 14 will be 14C1, right? So multiplying these two, what we are left with is 27 into 14. Okay. This much amount of way are there to choose one boy and one girl to represent the class for a function. Okay. So whatever it is, so it will be what? It will be 27, so it will be 270 plus 27 into 4, so it will be 80 plus 28 is equal to 108. So it will be 370. Okay. So this will be actually the answer. Okay. So selecting a boy from among the 27 boys and selecting a girl from 14 girls, that is what we need to consider in different ways, and then we can actually multiply those two. Okay. So the first, there can the for the first, this can be done in 27 ways, that is selecting one boy out of 27. Okay. So it will be 27 ways are there. For each boy it will be one way, so 27 boys are since there, so it will be 27 ways. And same goes for the girls, since 14 girls are there and you need to choose only one, so there are actually 14 possible ways. Okay. So 27 into 14, that is equal to 378. Okay. So this is what we need to consider as the answer. Okay. So let's go forward to problem number 4 and let's see what it brings to us. Okay. So let's actually try to see in question number problem number 3. If it would have asked you that there are 27 boys and 14 girls, and what you need to answer is, you need to answer if you need to select what? 2 boys. Let's say you need to select 2 boys and 1 girl. So how you can actually do it? Okay. So the question here is, do permutation matter here? Okay. Or will it be ignored? Okay. So that is, will combination be used here? Okay. So because you are selecting a committee, so as you can remember that in the second class while teaching you combination, I told you that while forming a committee we actually use combinations. Okay. Because in a committee the order doesn't matter. Okay. If you sit someone somewhere, okay, if there is a row where you need to sit, then the order matters. Okay. That is where permutation come into place. But in this case we are forming a committee or some representation of the class. Okay. Something like that, where order doesn't really matter. So here only combination will be used. So let's try to see for this kind of question what will be the answer. So the answer will be 27C2 into 14C1. If there would be 2 girls, so let's say 2 girls, so it will be 2. Okay. So here also the order would matter because of the same reason. So it will be what? 27 into 26 by 27 into 26 by what? So it will be 2 factorial into 25 factorial. Okay. So 20 factorial, 25 factorial will be cancelled out. So what we are left with is 2. So it will be 27 into 13 into. So it will be multiplied with what? So 14 factorial by 2 factorial into 7 factorial. Right. 2 factorial into 12 factorial. Okay. So this much into what? So it will be 14 into 13. So 7 into 13. Okay. This is what the answer will be if the question is modified in this manner. Okay. So let's go forward to solve actually problem number 4. So in how many numbers are there between 99 and 1000? Okay. Having 7 in the units place. Okay. And how many numbers are there between 99 and 1000? Having at least one of their digits as what? 7. Okay. So let's try to see. So in how many numbers are there between 99 and 1000 having 7 in the units place? So between 99 and 1000, what you have is you have only 3 digit numbers, right? From 100 to 999 you have 3 digit numbers. So what you want to know is you want to have 7 in the units place. So 7 is here. Okay. So you have only 2 options remaining. Okay. So in the 100th place, can you place? So how many choices are there? So you must be wondering 10 choices, right? 0, 1, 2, 3, and so on up to 9. But actually you can't place 0 here, because after placing 0 here, the number actually becomes less than 99. Okay, which will be a contradiction. So we'll have only choices from 1 to 9. Okay, so here actually 9 choices are there. Okay, but for this you can use 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, it won't matter. So you have 10 choices here, right? So 9 into 10 ways, that is equal to 90 ways. So I hope you have understood how I can actually solve problem number 1. Okay, so if it would have been asking you, okay, if how many numbers are actually there between 99 and 1000 having 7 in the word in the 10th place. Okay, so again you have 3 numbers only. The three digit numbers are only possible. So 7th is in the what? 10th place. So only 2 choices are remaining, right? So for this you have how many choices? So you have 9 choices. And for this, because 0 can't be here, okay, otherwise it will be less than 99. And for here you have what? You have 10 choices, so it will be also 90. Okay, so if I ask you uh, how many numbers are there between 99 and 1000 having 7th in the 100th place? So you have 7 right here, and there are 2 choices remaining. Okay, so for this, how many choices are here? You have 10 choices. You have 10 choices. Okay, so what are, so 100 choices will be there. Okay, so this is how actually these kind of questions play around. Okay, there is nothing very hard about these questions, but very basic, and actually it depends on your intuition and how analytical your thinking is. Okay, so develop those skills according to that and solve these questions in what? Seconds. Okay, like 2 to 3 seconds you can actually answer these kind of questions. So let's go forward and see the second bit of this question, that is problem number 4. So how many numbers are there between 99 and 1000 having at least one of their digits 7? Okay, so now the question becomes a little bit trickier, but it is not really that tricky. So you must be wondering that up to this we haven't used permutation or combination. Okay, so this is the question where actually we will be using those concepts. Okay, so again, between 99 and 1000, okay, all you have is a 3-digit number. Okay, so you have a 3-digit number only. Okay, so you have a 100th place, you have a 10th place, and you have a unit place. Okay, so what we want is we want at least one of the digits as 7. So there are 3 cases. Okay, that is 7 is in the 100th place, and 7 is in the 10th place, 7 in the unit place. Okay, so we have actually answered this, that is in the unit place, that is equal to 90 ways are there. And for this, that is 7 in the what? 10th place, we have also evaluated as 90 choices are there. And 7 in the 100th place, we have actually evaluated that 100 choices are there. Okay, so for this we have 90 choices, for this we have 90 choices, and for this we have 100 choices. Okay, so basically there are what? 100 plus 90 plus 90, that is equal to 280 choices are there. Okay, so basically 280 numbers are there where at least one of the digits it's 7 between 99 and 1000. Okay. So let's try to see the step-by-step solution. First, it's important to observe that all of these numbers consist of 3 digits. Okay. So 9 is situated at the units place. Okay. So basically, as you can see here, only 10 into 9 is equal to 19 numbers ranging from 99 to 1000 that actually feature 7 in the unit place. Okay. And same goes for the third. In the middle digit, we can also, that is the 10th place, we can also use the same, and we can evaluate that there are actually 90 choices. And for the 10th and the 100th place, we have actually 100 choices. So summing them all, what we are left with is what? 280 choices. Okay. So let's actually go forward to the problem number 5. Okay. So in how many ways can 5 children be arranged in a line such that two particular children of them are always together? Okay. So two particular children of them are never together. Okay. So in how many ways can 5 children be arranged in a line such that two particular, so basically there are 5 children, so they must be distinct, okay, because every other person in the world is actually distinct, okay, in terms of their DNA. There is no DNA that is 100% same. Okay, so you can say that all those 5 children are actually distinct, that is different. Okay, so two particular children of them are always together. Okay, so basically, this questions come to that book question. Okay, similar to that book question where you have actually 5 books and always two are together. Okay, let's do that actually. Let's name them C1, C2, C3, C4, and C5. Okay. And then two particular children of them are never together. One question is this, and one question is this. Okay, so when arranging the children for the part I, okay, that is they are always together. So we group two specific children together, treating them as a single unit. That is how we actually approach this kind of question. That leaves with 4 remaining. So there are basically 4 factorial ways and equal to 24 ways. Additionally, the two particular children when grouped together can be arranged in two different ways. So 24 into 2, that is equal to 48 ways are there. So let's try to see the what second kind of option, that is out of the total 120 permutations possible for the arrangement of 5 children, there are 48 permutations where the two children are positioned together. So the remaining are what? When they are not positioned together at all. So it will be 120 minus 48. Okay, that will be what? 72. 72 will be that answer. So let's actually go forward and see the problem number 6. So in how many different arrangements can you make using the letters of the word apple? So you have the word apple, A-P-P-L. Okay, you have 1, 2, 3, 4 letters. Okay, P is repeated twice. So the word apple has what? 5 letters with 2 P's and 3 unique letters. So to find the number of arrangements, you use the formula for permutation with repetition. Okay, so calculate what? 5 factorial by 2 factorial to account for the repeated letters. So simplify the expression, we get the answer equals to what? 16. Okay, so in how many ways can the letters of the word Mississippi be arranged? Okay, so basically while arranging and distinct, not distinct objects, n objects, okay, where some objects are repeating itself. So how you do it? First you try to what? Do the factorial of the number of digits or letters there. So 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 factorial is there. So let's see how many times m is repeated. 1. Okay, so how many times I is repeated? 1, 2, 3, 4. So it will be 4 factorial. Then how many times s is repeated? 1, 2, 3, 4. So 4 factorial is again there. How many times p is repeated? 2 factorial. 2 times, so 2 factorial. So whatever the value is here, so that will be actually the answer. So in how many ways we can do this? So in this many ways, that is 11 factorial by 4 factorial into 4 factorial into 2 factorial. Because what? In Mississippi, I is repeated 4 times, S is repeated 4 times, and P is repeated. I is 4 times, S is 4 times, and P is 2 times. Okay, and total numbers are 11. So it sums up to be what? 34, 650. So let's try to see actually how many distinct arrangements can be made with the letters of the word bookkeeper. Okay, what we want to do is we want to take distinct arrangements. Okay, so we will use the same formula: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 English letters are used here. So 10 factorial. Okay, then let's try to see. B is repeated once. 1 factorial. O is repeated twice, 2 factorial. K is repeated twice, 2 factorial. E is repeated twice, 2 factorial. P is repeated once, 1 factorial. E is actually repeated thrice, so it will be 3 factorial. R is repeated once, so it will be 1 factorial. So let's try to remove 1 factorial. So what we are left with this much. Okay, 3 is 2 K's, 1 B and 1 R. Okay, and 3 O's are there. Actually 2 O's are there. Okay? 2 O's are there. So to find the number of distinct arrangements, you use the formula for permutation with repetition. Okay, so it will be 3 factorial by 2 factorial and 2 factorial to account for the repeated letters. So it sums up to be but 1,51,200. Okay, so let's try to actually solve problem number 9. So if all the permutations of the letters of the word again AGAIN, where you can see all the 5 letters actually distinct, that is different, are arranged in a order as the in a dictionary. Okay, so what is the 49th word? Okay, so the process begins with what? Letter A, because in a dictionary it comes in what? Alphabetical order. So in alphabetical order A comes first. So and by arranging the remaining 4 letters A, G, I and N. Okay, so there are basically total 4 factorial permutations. Okay, so which result in what? 24, because 4 into 3 into 2. So how much is this? So it will be 12 into 2, that is equal to 24, right? So these 24 words constitute the initial set. So next what we do is the arrangement starts with the letter G. Okay, then letters A, I, N. Then arrange differently. So in this case, there are actually 4 factorial by 2 factorial into 1 factorial permutations, resulting in 12 words. So okay. So moving on to the 37th word. In this sequence, it starts with the letter I. And in the subset, there are once again 12 words that begin with I. So this accounts for the sequence to be up to the 48th word. So finally, the 49th word is spelled what? So it is spelled as Nagi. Okay. So problem number 10. So in how many ways 3 mathematics books, 4 history books and 3 chemistry books and 2 biology books can be arranged on a shelf so that all the books of the subjects are actually together. So basically 3 mathematics books are there, 4 history books are there, 3 chemistry books are there, 2 biology books are there. So all the similar characteristic books should be what? Considered as 1. So 3 mathematics books as what? M dash, let's say, and 4 history as H dash. 3 chemistry books as what? 3 dash or C dash, and 2 biology books as B dash. Okay, so you have what? How many different characteristics? 1, 2, 3 and 4. 4 type of books. So 4 factorial ways are there to what? Order these. Okay, so inside them actually 3 mathematics books can be ordered in what? 3 factorial ways, and 4 history books can be ordered in 4 factorial ways. 3 chemistry books can be ordered in 3 factorial ways. 2 biology books can be ordered in 2 factorial ways. Okay, so this many ways are there. Okay, to make the what? This is the number of ways we can actually place all these things. Or else what we can do? We can also do what? So 3 plus 4 plus 3 plus 2. So how much is this? So it will be 3 plus 4. So 3 plus 4. Okay, it will actually be this much amount. So let's go forward with problem number 11. So a student has to answer 10 questions. Okay, choosing at least 4 from each parts A and B. If there are 6 questions in the part A and 7 in part B, in how many ways can the student choose 10 questions? So he needs to answer 10 questions. Okay, choosing at least 4 from part A and B, and there are 6 questions in part A and 7 in part B. Okay, so in how many ways he can do it? So select 4 items from part A and 6 items from part B, and choosing 5 items from part A and 5 from B. So summing these all up, what we are left with is 266 as the correct answer. Okay, so I believe that's enough for today. And by doing all these kind of variety problems, okay, what I can say is you will have enough confidence to do some previous year question. But before that, we'll actually do some more exercise problems so that your base is actually stabilized and you are but somehow confident about the PYQs. Then we'll do some PYQs so that you could see that in exam what kind of questions are there asked and how you can actually approach those questions. Those are not very difficult questions. Okay, there may be have some sort of small trick, but not very mind-boggling questions are there. So it is very easy to actually do exam questions if you are prepared well. And what you have is a clarity of thinking. Okay, so I believe you have enjoyed this lecture. So thank you.